So from last time, we already have the observations, okay, and the propensity that we developed using logistic regression. So we're going to copy paste that information from sheet 2, okay, over to sheet 3. All right. Okay. So how did we do lift chart in when we had interval target? Okay. We have y, the target value and the predicted value y hat. We sort this by the predicted value and then do a cumulative actual value and then plot that and then see whether that the observations sorted by y hat sorts y also quite well. So if it sorts y also quite well, then the prediction is good. So this is when your objective is not actually predicting a single observation, but rank ordering a group of observations that may be coming in. It's the same case here. When we are trying to predict a single case, single observation, then we do the classification matrix or confusion matrix and see what is the misclassification rate and the cost for that and so on and so forth. But here it is about ordering. So once again, we need to sort this by the propensity. So here propensity is the equivalent of y hat. In fact, it is y hat, okay, as in the interval interval target. So well, we won't sort the case number will remain the same. Okay, so the rest of it, okay, sort by propensity. Okay, so propensity, largest to smallest. Okay. All right, so now so we need to do the actual class. So here we have to plot the class value, the cumulative class going from top to bottom. So we're going to have to recode the target into 0, 1. So then we can add them. So you cannot add owner and non-owner because that's text value, right? So owner being our class, so let's put that outside. It's usually a good practice never to use actual numbers or text values in Excel formulas. So you need to put those parameters outside. So let's do class of interest, right, is owner. Right? So if that is equal to that, and that should be absolute reference, then we recode that to a 1, otherwise 0. Okay. Then we have the cumulative, and here is another way of doing the cumulative. So the first one is just that, and after that it is the previous cumulative plus the current actual value. So this will also generate cumulative class. So now we will plot the cumulative Okay. Let's do a line plot. Okay. Cumulative actual. Now we need to compare this against benchmark, which is naive. So the baseline is x is 0, y is 0, x is 1, y is actually x is 24, x is 24, because there are 24 cases, okay, and y is 14, I'm sorry, y is 12. 12 is the maximum number, so y is 12. Okay. Now for this to work, I'm going to change the, so go to design, change the chart type from line graph to scatter plot, and let's select that one. Okay. So now we have the cumulative actual, and we add the benchmark. Okay. Select data. All right. Add. All right. X is that. Y is that. If you add a 0, 0 before that, then the blue line also will begin with that. So this is your lift chart. Where the separation between the baseline orange line and the blue line is what's important. So this area under the curve. So we'll talk more about area under the curve a little later on, especially when we revisit ROC chart. We've already done ROC chart. We've introduced ROC chart last time. So we have some more things to discuss on our ROC chart, which we will later on. So here, the faster the blue line reaches the maximum point of 12. So if it steadily increases to 12, and then, the best chart would be blue line increasing straight all the way up to the maximum, and then flat the rest of the way. So that would be the best lift chart. Yeah, that's right. So everything was correct in that case. Of course, it's not going to be that perfect. So, but the faster it reaches the maximum number of events, the better the model